Hello everyone, I'm Bradley Sward, Associate Professor of Computer and Information Science at the College of DuPage in Glen Ellen, Illinois. This video today is Day 18, Part 1 of the 2021 Advent of Code. The problem is called Snailfish. If I sound a little labored and tired, it's because many reasons, but mainly, I know it's all relative, but they pretty much, did they up the difficulty? Day 17 was pretty simple stuff. So day 18, not so much. So here's the problem for those of you who want a little elaboration of the rabbit hole that 10,000 people plus have gone down in the last day or two. So there is Snailfish and there's math. There's math. And basically a number, in one of our numbers is just 2 or 4 or 8 or pi or something like that. And of course, these are all just integer values. At least I hope they're all just integer values. I haven't gotten to part 2 yet. And so, but in this case, they're pairs, kind of like complex numbers in a way, right? Except that each part of the pair could also be a pair. So it's a recursive nightmare. It's just a recursive frickin' nightmare. And so all of these are valid numbers in this Snailfish language or mathematical language. And of course, we're only talking about addition here. Like I'm wondering what part 2 is. I know nothing about this. I don't even know if my part 1 solution is correct yet, which I will be showing at the end of this video. And I'm gonna cry either way. I'm gonna cry if I make it or cry if I don't. But so I'm adding these numbers together and there's rules that we have to follow. And so basically you look through a bunch of numbers here and you go like something like this and you go, if there's a pair that's nested at least 4 deep, or in this case, like 4 deep, they say that if a pair is nested within four pairs, because this pair is nested within this one, which is 1, 2, 3, 4. And what you do is you take this number and you try to add it to whatever's to the left of it, the number that's to the left of it. You take this number, you add it to the right, and then you take this whole list and you just replace it with a 0. And so in this case, everything goes to the left. There's nothing that can go to the left. The 8 can go to the right, so it turns into 9, and then this thing is just replaced with a 0. So there you go there. And then just looking its way backwards on going to the left-hand side, like there's nothing, that 2 just disappears to the right, but the 3 gets added into the 4 over here, and then this whole thing gets replaced with a 0. And that's what's called an explosion. Kaboom! Kaboom, kaboom, kaboom. And so that's one of the 2 things that we're going to be doing here. And then the other thing that we're going to be doing here is what's called a split. If any number inside of any of these guys here is a 10 or greater, like this guy here, it gets split up into halves. Basically a new list. That one number becomes a list of numbers. And basically you cut it in half, and if you need to add 1, you add it to the right-hand side. That's just arbitrary. Seems arbitrary. Is it arbitrary? I don't know if this has a real-world connection. I am not that kind of mathematician to be able to say that. But anyway, so those are the 2 kinds of operations you can perform on a single snailfish problem here. And so you can take one of these things like this. If I want to add these 2 things together, it takes a lot of operations to work down into a way that you cannot reduce it any further following those 2 rules. So the rules are, if there's a nest, basically explode it, and if there isn't any, then you can go ahead and see if there's a split and go into, keep applying these rules until there's nothing left. So that's the general process. And so they give you like 100,000 examples, and I think I've gone through, I think I hit every branch on the way down on this one. And so at the end of the day, you work your way through, like if you take this plus this plus this plus this plus this plus this, and working its way down all the way, you get this number right here, this final sum from this. And so the question is, and then, oh yeah, forgot about all that. And then once you finally work your way down, now, of course, that couldn't be enough, I guess. You couldn't just put a number in there and be done. So now we have to recursively go through and figure out the magnitude of this thing by basically saying, take the left-hand side, take the left-hand item, multiply that by 3, add it to the right-hand item, multiplied by 2, and it's recursive, so so if there's a left-hand side that isn't just a number, you multiply the result of that whole thing by 3, and then you multiply the whole thing by 2 on the right-hand side if that happens to be a list and list of lists. And that turns out to be probably the easiest part of everything. It sounds like that part of the recursion sounds complicated, but it pretty much gets you to the end here. So at the end of the day, I don't have an answer. Here is my puzzle input, all of this good stuff here. So let's take a look at my code. So, okay, and then before I talk about it, here is the list of 100 Snailfish numbers that are going to be added together to get me to the dance here. And so here is my code. I'm going to need JSON for the loading of the data, because I am not writing that. I'm not writing that code to parse that string and make it into a list in Python. Thank goodness there's just thank goodness for whoever wrote that code. Thank you very much, that person. And so in this, you can just take this string of data, and now after I run this, when I run this, you can see that I generously have 100 items inside of this thing, and for whatever reason it won't I don't know why it won't show me more. I won't fill in the gaps. Maybe that's something I can kind of change in the settings. It is kind of annoying that I can't see it's just dot 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 dot, like, okay, that's not really helpful, but there's 100 of those things there. And so my approach ended up being a binary tree of sorts, because every number has 2 items. It's got a left-hand side and a right-hand side. And so I needed to set up a node class, and in Python it's relatively simple. And I really was wondering, it was one of those things, because I've been working with Python, but I'm like, I really need to understand how reference types and how value types and value reference types and value types and all those things kind of work together in Python. And oh boy, did I get my lesson this time. I got a binary tree working without ever thinking about it before in Python. So good for me. So how long am I? 7 minutes talking already? Well, okay, I'll get going here. So I have a node class that keeps track of it, the value, meaning the string of data, the depth, how deep is this thing into the recursiveness. And then it turns out I don't even think I used the left and the right. I could probably at least erase that out. I do need the parenting for later on. You'll see that when I get there. And so then I have this function called make tree. So what I do for a specific problem is I take that string, that list of lists, and I turn it into a binary tree. And so I'm not the terminal nodes basically of this are, if there's a number, I don't push it any further. I could go and I could create a node just for an integer value, but I figured there was no reason for that. Maybe it would make things a little simpler if I did, but I did not do that. So anyway, but here's my node class, here's my tree, and basically I'm adding a node, which is just the whole item, and then I'm breaking it up into sub pieces and recursively doing that if I need to along the way. And so then there's really no way I can show this graphically when I do this anyway, because I'm not spending the time to set up a graphical description of the tree structure in which I'm creating. Okay, so that's basically, and then what I'm going to do is I'm going to take that tree, and the tree is holding references to all of the lists that make the thing up. So now when I go ahead through the tree and I make modifications to tree nodes, I'm actually making modifications to the real data, which is what I want to do, as opposed to making modifications to copies. So that is so that's that. And I need these 3, my thing fall down here. And I need kind of like 3 global variables to make this thing work, at least for my implementation. The value variable is going to be basically, is going to store either the explosion or the split at the point it needs to do the splitting or the exploding. So it's going to be basically just a list or just a number or whatever it needs to be. And then this is going to be, as I'm recursively going through, I'm going to see, did I find what I'm looking for yet? Because what I'm going to do, I'm going to work this both ways. Because one of the tricky parts was, okay, it's relatively easy to find what you're looking for. Find me the node that, basically that needs to explode. But how do I find the node, or how do I find the exact item of where I need to put the guy to the left and put the guy to the right? And then what happens if none of them exist? So what do I do then? And so that's where my idea of the node stack comes in. and that when I'm generating that and I'm trying to find the node that needs to be modified, at least for the explosion, that I'm keeping a stack of all the nodes that I'm progressing through to get to that point. And so what I can basically keep it like a stack, and if I go through it in reverse, that tells me basically I can test to see, basically go through there and go in, like test the top node and go, okay, you were the last one that was touched. Hey, do you have an integer in there? And you go, yes. Okay, cool. I can use you as the one that's going to be modified. And the same goes right to left. So I have two functions that go, one goes left to right through or if you want to think of it in order, I guess in order, like from low to high. And then I have one that goes in order high to low. And they both work out just great because then it gives me a stack of items in which I just find the first one and then I'm done. And so I think that's a pretty good situation here. So this function, my code starting out was, for this tree stuff was pretty slick, and it was working for, it's like oh, for what it is, it was not a lot of code for setting up a tree and working with it, and then the magic happened. So what I'm doing here with the in order explosion is just trying to find the first place in here where an explosion can occur. And that is as easy as just going, as I'm going through my map and just trying to find the first, or not my map, my tree, trying to find the first place where the depth order is 4. And again, nothing's ever going to get greater than 4 because of the way the things work out. And so once I hit 4, I go, here it is, and then I let everything else do its magic. But even if it does so, I put this if check in here, but this no one, so that you can't go in and modify it twice because I want the first one. And so that is how I get for an explosion, that's how I get to what node needs to explode. And then once I have that, I have this little fun function here, look at this guy here, to get me that stack, and then to get me that stack of information so that when I go, okay, what is the closest true number to the right of the node that needs to explode, I'm just working my way back through the stack, and once I find it, I basically set up that value, add it to there, and then I'm done. And then I break out, and I don't have to worry about it anymore with all the code that I wrote. So again, this works the same exactly. It is exactly the same code right to left versus left to right. The only difference is in the order in which I do the progression through the tree. So for this, trying the right number, I do the right node first if it exists, and then I do the left node second. And then here for the left node, I do the left node first, and then I do the right node second. Okay, so then as I was saying, when I want to try to explode something, I call my function and it'll tell me, oh hey, something exists, it needs to explode, and then it'll go ahead and say it'll change the left number if it exists, then it'll change the right number if it exists, and then it replaces the list itself with a 0, and that's what this part is doing here. And then the same kind of thing applies for the split. Surprisingly, I had more trouble with that, even though it was an easier operation to think of. But it's the same idea here, where I'm just trying to find the first node that in which that will work. And it just got a little tricky. There was one edge case that was blowing my mind for a little bit when it came to how to figure out, if you have a list on the left and a list on the right, how do you know how to progress through? So that one threw me for a loop, and it took me quite a while to get through and find, basically debug and find the exact point of the breakage, because if you could imagine, there's a ton of splits and explosions that go on for any one of these numbers at any given time. So I had to get maybe 50 or more, and then you're like, oh, there's the one, and then you can kind of work your way backwards and debug to figure out what you did wrong. Because if you've ever worked with recursion like this, you go, everything just looks like complete nonsense until it all just magically kind of works together, and that's just kind of how things go. So these two functions work together. I use the in order split to get me the node, and if it exists, then this is the code that basically sets up and converts that one number into a pair, a 2-item list that goes in its place. That's what this code does here. And so then the add function was easy, because you just take whatever's on the left-hand side, and that's the left-hand side of a list, and you put whatever's on the right-hand side, you put that on the right-hand side of the list. And then the magnitude was actually relatively simple too. The code doesn't maybe look as simple as it could, but if you want to think about it, you say the left-hand side is 3 times whatever it is. So if it's an integer, just multiply it by 3. Otherwise, multiply it by the recursiveness of take that left-hand side and figure it out and give me the 3 times that. And then I take whatever that is and I add the same thing for the right-hand side, but I add 2 times that and return the value. And with this little bit of magic, all the recursion does all. So getting closer and closer here to the final deal here. And then the final code, starting with, and this basically just goes through for every item in here, all 100 additions. It just goes through. And again, the rule is if there is an explosion, you have to do it first before you even attempt to split. So you have to, that was the rule in order. If there's an explosion, do it, then go back up and try again to see if you can do another explosion. And only when you can't do an explosion do you think about doing a split. And when you finally can't do either an explosion or a split, then you know that you're done for that specific number. That number can't be reduced anymore. And 16 minutes in, here is my hitting F5 here. Oops, I don't want to. Hitting F5, run this, and it prints out everything here. I made it so like you can see all the operations print out here as they go through. And my answer for this is 4088. And here is the magic here. I'm going to go over there right now, and I will see if that is the correct answer for part 1. All right, as promised, here we go. I'm going to cry either way. Oh, thank God. Okay, that's part 1. I did it. I only took my sanity and everything else. Anyway, so now part 2. My guess, I'm kind of guessing it could be a couple things, but my guess would be because the numbers kind of slough off. So what is maybe what's the maximum value? I don't know. Let's see. Oh, what is the largest magnitude of any sum? Yeah, pretty much that was exactly what I was thinking. Because I'm like, well, oh, wait. Snailfish edition is not commutative. Okay, this is for another time. You guys have... Whoever's watching this at this point, you deserve a star on your own right there. You get the Brad Sward Gold Star of Advent of Code. And it's worth absolutely nothing. So that covers this part 1. And I'm going to take a little break, and I am going to, not that it matters or anything, and I'm going to take a look at this. Apparently it's pretty simple since, you have to, for any of the 2 numbers in the homework. Oh, that's not so bad. You just do this 9th or 5,000 times or whatever. How many times? 5,500 times or something like that. Just try all the different combinations out and see what you get. And, well, I'll do that, and then I will come back with a part 2 video. So thanks everybody for sticking with it. I'm still doing this stuff. Finals are over, but the holidays are coming up, so I think a lot of people are the same way, where it gets a little more sporadic with everybody trying to solve these problems. So have a good one, everybody. I'll see you in future videos. Have a good time. Have a good one. Take care. See you then.